In this session, we'll explore the basics of Python lists, a flexible way to store and organize data. We shall start by learning how to create lists using square brackets and commas. Lists can also hold different types of elements. Next, we'll understand indexing and slicing, which help access individual items or parts of a list based on their position. We'll also look at some basic list methods that allow us to add, remove, or modify list items easily. Then we'll touch on nested lists, lists within lists, which help represent structured data. Finally, we'll introduce list comprehensions, a quick and clean way to create new lists using simple expressions. Lists are an incredibly flexible and commonly used way to store and organize data in Python. Think of them as containers that can hold items in a specific order, just like a to-do list, a shopping list, or even a playlist in your music app. A list is basically an ordered sequence of items. This means that every item in the list has a fixed position, and that position is preserved unless you change it. Lists are useful when you want to group multiple items together while still keeping track of their order. What makes lists especially powerful is that you can hold a variety of object types. You can have numbers, strings, even other lists all within a single list. When creating a list in Python, we use square brackets to enclose the items, and we separate each item with a comma, just like the example shown here. You don't need to memorize the syntax right now, just understand that a list looks visually like a sequence of elements grouped together. Later we shall see this in code, but for now just picture it as a bracket opens the list, the items are placed one after another, separated by commas, a bracket closes the list. Because lists are ordered, each element has a position, or what we call an index. This allows you to directly access or manipulate any item in the list by referring to its position. For example, if you had a list of 5 items, the first one is at the top of the order and fifth one is at the end. The ordering is very strict, and that's one of the key strengths of lists. You always know where things are. Lists allow you to do indexing, which means you can refer to specific items by their position. They also support slicing, which is like taking a part or slice of the list, just like selecting part of a cake. This makes it very easy to extract subgroups of data, rearrange things, or perform operations on specific sections of a list. Again, we look at actual examples later, but remember, indexing helps you access individual items, while slicing helps you work with multiple items at once. One of the more advanced but really useful features in list is that it can contain lists inside a list. This is called nesting, and it's like putting boxes inside a bigger box. It allows for representing more complex data structures like table or grids. Additionally, lists come with a set of built-in methods, little tools you can call to do common tasks like adding or removing items, sorting the list, counting how many items an item appears, and more. You don't need to memorize this right away, but just know that Python gives you many tools to work with lists easily. Let us now jump to the Jupyter notebook and see whatever we have discussed till now practically. So let's first assign or create a list. So what I will do is that I will first write my list equals to, so I said open the square bracket and close it, and inside it I can write the element of the list separated by commas. So if I now write my list or try to output my list, you can see here 1, 2, 3 are the elements in this list. Now as I said, list can also contain different object types. So let me give an example. If I just reassign this list, my list equals to open and close square bracket, I write 1 comma 101.2 comma and another string, something like say string, and then execute this line and I will print the my list or show the output of the my list. So if you see here, a list can contain different kinds of data. Now just like strings, list also has a len function which basically tells you what is the length of the list. So for example, len, if I type my and then give tab, it will show me the option and then execute this line. It tells me there are 3 elements inside this list. So let's now show some indexing and slicing, which we have discussed previously in the beginning of this session. Just like we have seen in strings, we can do the indexing and slicing in list. So let us first grab, or let's do one thing. Let's first reassign the list so that to make it little bit more interesting. So I'll say here the my list contains apple, comma mango, comma orange, and then 2 integers. Okay, so let me grab the first element. So what I will do is that I will grab the element which is at index 0, and remember the first element is always at index 0. So if you see here, the output is apple. Now also I can grab the first, or I can say that I can grab the element at index 1 and print rest of the elements, or grab rest of the elements rather. There was a typo here. I can say my list, open and close square bracket, and I say index 1, and after colon I am not giving anything. So if you see here, it is grabbing from index position 1 and everything after that. So I hope you remember this also from our discussion on string. So what I can do is that if I want to grab everything from the beginning, I just leave this space blank before the colon. So for example, I will say my list, open and close square bracket, I don't write anything and give colon, and I want to grab until the index 4. So this is 0, 1, 2, 3, 4. So it should print until 4. So the last index is left out. So if you see here, it is basically printing till 4. We can also concatenate new items into the list. So how we do that is basically by using the plus operator. So what I can do is that I can say my list plus, say for example, new item. So if you see here, I have a new item in the list now. Now mind you, this would not change the original list. So let's see the original list. So there is no change in the original list. In order to make the change to the original list, we would need to reassign. So what does it mean is that I have to reassign like my list equals to my list plus new item. So this is how we can expand the list. So let me just print it and show it to you. So if you see here, I have a new item in my original list. We can also use the asterisk parameter which we used in our strings to basically uh, make the list double or how much we want. So for example, my list into 2. So if I press enter, you will see that I have 2 occurrences of the same list. Again, this would not change the original list, so that means if I just print the if I print the original list, it should give me the original values. So here you can see that there is no change. Those with experience in other programming language often relate Python lists to arrays. However, Python lists offer greater versatility. Unlike traditional arrays, they can grow or shrink as needed, and they allow mix of different data types within the same list, making them far more adaptive in dynamic programming needs. Now let us explore some of the special methods of lists. So let's do one thing. Let us create a new list. Say I would say list 1 is equals to 1, 2, 3. 1, 2, 3. I do shift enter. So in order to append to a list, we will use the append method. So what we can do is that list 1 dot append. So I can say here append me. Now if I print the list, you should see this element inside the list. The pop method is used to remove an item from a list. By default, it removes the item at the last position, but you can also specify a particular index to remove. Let's take a look how it works. So if I say list 1 dot pop and don't specify anything, and then it should have been list 1 here, not list, which is a keyword. Now if I type the list 1 here and then try to output it, you will see that the last element has been removed from the list. Now what we can also do is that we can basically pop out any particular or specific element by giving its index position inside the pop method. So if I say list1 dot pop 0, it pops out 1. So it means that there is a return value associated with it, because I didn't print it, but still it gave me an output. So it means that it has a return value associated with it. Now in order to basically say capture that value, what I can do is that I can assign it to a variable. So popped item, so let me just modify this only. Popped item, or let me rather write it like this using an underscore, how we have been writing till now, and then try to print it. So you will see that the popped item now is 2. Don't confuse it, we had already popped 1 out already, that's why now it is popping out 2. That's the reason you see 2 here. So now if I want to say pop out an item for which there is been, or in other words say an item from an index which is not available in the original list, say let me say list 1 and then say 150 or 145, and then I say shift enter, this would throw me an error because we don't have an index 145 in this original list. So if you do a mistake in the index, don't worry. Now let us see how some of the reversing and sorting methods work out. For that, let me assign or create a new list. I would say new list equals to some random values 23, 11, 2, 5 or 4, 5, 8. So let me output this list first. So to make sure we have the desired values. Now to sort out the list, we can simply use the sort method. So new list. If you type dot and press tab, it should show you so many methods which are there. So what I will choose from this is the sort method. Remember, you have to use the parenthesis at the end of each method, else Python doesn't understand that it's a method call for that particular cell. Now if I output the list, it should show you in a sorted order. I can also reverse the list, new list, and then say reverse, and then try to output the new list. You would see that the elements inside it are reversed. So these are the very few useful methods which I have shown you now. You can practice around a bit so that you get confidence about using the methods of the list. Also, one of the powerful features of Python data structure is the ability to support nesting, which we have discussed in the beginning of this lecture. This means we can create, or what we can do is that, in simple words I can say, is that we can create lists inside lists. So we can place one data structure inside another data structure. For example, let me declare three lists first. Say list 1 equals to 1, 2, 3, and then I would just declare another list 2, which I will give elements as 4, 5, 6, and then I will declare the third list, which is 7, 8, 9. Now, as I said, I can basically create list inside list. So what I will do is that I will create a new list called as matrix and put this list inside the matrix. So list 1, comma, list 2, comma, list 3, and then type shift plus enter. Now if I print this, you can see that the lists are inside list. So you have one set of opening and closing square bracket, and then you have another 3 lists inside it. Now we can use indexing to grab elements inside this bigger list also. So for example, I can say if I want to grab the first dimension only, I would say matrix 0. I can grab the elements in the second dimension also by mentioning the second dimension, which is one of the most powerful feature. I can write like this. I believe this would remind you of your mathematics matrices, which we have studied during our school days. Now if I just execute this line, you will see I can grab the element 1. So like this, I can grab any element of the data structure. So I can say that 1, and then I can say 2, or even 3. Sorry, 3 is not an index because 3 we have only 3 elements. The maximum index is 2. So now if you see here, 1 and 2 gives me back 6. So this is the element which we are grabbing. Now moving on, the last topic of the day, Python offers us a very powerful feature known as list comprehensions. I have told this in the beginning of the lecture, which basically lets you create lists quickly and efficiently. To grasp how they work, it's helpful to understand for loops first. So don't worry here if this section feels a little bit tricky for you now. You can skip it and later we shall revisit it again once we discuss about loops. So, but let me just show it how it works. So what I will do is that I will say first column equals to, within opening and closing square bracket, row 0 for row in matrix, and then I would just call this assignment which we have done, and you will see the output as 147. So what happens here actually is the code goes through each row in the matrix. So here we are calling the matrix. So in this matrix which we have created previously, the code go through each row in the matrix and picks the first number from each row. So here we have said first number in each row of the matrix. The loop or the for loop runs for 3 times, once for each row, and row 0 means takes the first item. So it takes 1 from the first row, 4 from the second, and 7 from the third, making it a new list 1, 4, 7. You don't need to think around it too much if you have not understood, because we are going to revisit this again once we study our for loops. So that's it for the lists in Python. See you in our next lesson.